Hello, math students. Today we are still working with writing linear equations. So we're going to be writing equations in slope-intercept form, but yay, we get to work with story problems today. Everybody's favorite, right after fractions. Probably fractions are your favorites. So I'm going to be giving you situations where we have to decide basically of the numbers that I give you, which one is the slope and which one is the y-intercept. The y-intercept is the thing that happens one time. It's the beginning amount. And then the slope is how things are changing throughout the situation. So for this first one, I've got a car rental company charges $120 to rent a car for 3 days and then 50 cents per mile. And that's a typical way that you would rent a car. You have to pay, just use the car, but then you also have to pay for how much you drive it because there's more wear and tear the more that you drive it. So I want to be able to figure out this as an equation. Notice they're telling me variables to use. Instead of just saying use X and Y, they're going to use letters that are going to make sense in the situation, right? So the cost that we're going to find, instead of saying Y equals, we're going to say the cost equals. Now, I've got to pay 50 cents for every mile. Every mile that I drive, I spend another 50 cents. The $120 I don't pay for every time that I drive a mile. That's only happening one time. So the y-intercept is going to be that 120. The m, the slope, is going to be the 50 cents. Now, we're not going to use like that dollar sign necessarily. We could just go with 0.5 or 0.50, 50 cents for every mile, plus the $120 that I started with, right? That's how we write the equation. Now, I should be able to also ask you another question when we're done. How much would it cost to drive 200 miles? Okay, now the nice thing about having different variables here instead of x's and y's is that it kind of tells you what you need. I'm driving 200 miles, that's my m. So I'm gonna put a 200 right there. So 0.5 times 200, it's really half of 200, that's 100, plus the $120. Now here's the substitution. 0.5 times 200, we said that one's going to be 100. 100 plus 120 is going to be 220. Now, when we say dollars, do not put that dollar sign after the number. You guys are smart. You guys can handle putting that dollar sign in front, even though you say it after. Okay. This is not necessarily the way that we pay for phones now, but it used to be that you would have to pay for having a phone, and then you'd also have to pay per text message. So we've got this phone that's $59 a month, and it's 15 cents for every single text message that I write or receive or whatever. So I want to write an equation. So C is going to be the cost again. X is the text messages, right? So the cost for this phone. I have to decide which of these things happens one time. Again, the $59, that's what happens one time every month. The 15 cents, that's what's happening. That's the slope. That's how it's increasing. Every time I get a text message, every time I send a text message, my total is increasing by 15 cents. That's how it's changing. So I would have 0.15 for every text message plus just the cost of the phone in the first place. Now, what if I have 500 text messages, right? That 500, I'm going to put right there for the X. So the cost would be 0.15 times 500 plus 59. This is a great place for a calculator, by the way. So we're going to have 500 times 0.15 is $75 just for those text messages, plus the $59 that we had to pay just to get the phone. So this is going to be a total cost of $134. By the way, we're just going to do a whole bunch of these examples, getting practice with which number is the slope, which number is the y-intercept, and then substitute something in. So Jed has saved $120 for a new bike. He's also planning on saving another $25 every single week. So he's really trying to be consistent in his saving. Write an equation to find the total amount of money he will save over however many weeks. So T is going to be the total money that he saved. He's saving this much money. The 120 and the $25. The $25 is what's happening every single week. That's my slope. The 120, that's what he begins with. That's my y-intercept. So this is going to be $25 for every week plus the $120 that he had to start with. So if I want to know how much money he has in 8 weeks, I would put the 8 in for the weeks, right? 25 times 8, that's going to be 200 plus 120. That should be $320 that he's going to have. So Jed was saving for a bike, but Ned wants to buy a car. And the car costs $3,000. He plans to save $150 every week. We want to write the equation to figure out how much money he still needs to save after a certain number of weeks. Now, this is written differently than all the other ones. We always were saying, how much does he start with? And then he's saving more money on top of that. This one, we're really looking at, he's got to get up to $3,000. So the amount of money that he still has to save, every week, he's saving $150. So he's actually decreasing the amount that he still needs. But we still have to decide here, slope and y-intercept. The y-intercept is, this is how much he's beginning with, what he needs. This is how it's changing every week. But since he's saving that money and it's decreasing the amount of money that he still needs to save, we would say that that's a negative 150 because we're really looking at how much more he has to get. So it's decreasing by $150 each week, but he starts by needing $3,000. Now I'm going to take that equation, move it up to the next slide. There it is. I want to know after 14 weeks how much money he still needs. So this 14 is going to go in for the number of weeks. So the money that he needs, negative 150 times 14 plus 3,000. So 150 times 14, this is going to be a negative 2,100 plus 3,000. That means that he still needs $900 more. So after 14 weeks, he's down to only $900 that he still has to save. All right, now using that same equation, I want to know how many weeks it took him so that he was down to $1,650. Now this is a different kind of a question than what I've asked before. I want the amount of money that he still needs to save. I want this number to be the $1,650. So we haven't done a problem where we're substituting there, but we certainly can. If I say 1,650 equals negative 150 plus, negative 150W, plus the initial amount. So to solve this, you guys are good at solving equations. Draw that vertical line if it helps you. I have to get rid of this 3,000, right? I'm trying to get the W by itself. And don't freak out because that's going to give me a negative number because I have a negative 150. So if I have 1,650 minus 3,000, I'm going to get a negative 1,350. And then I'm going to divide by negative 150. So that's going to give me 9, and I kind of ran out of space there, so I'm going to write it over here. 9 weeks. So when he hit 9 weeks, he had 1,650 left to save. All right, same situation. Now I want to know what number I'm going to substitute into this equation so that I can figure out how long it's actually going to take. How long it would take him to get the $3,000. Now remember, the M here stands for how much money he still needs to save. If he has now saved all of his money, that would mean that this money number right here should be down to 0. He wouldn't need any more. So I could substitute in that 0. This one doesn't specifically say to solve this, but I'm going to. By the way, I would totally expect you to look at this problem and probably not even write the equation. But if we have this equation, I want you to see how we can use this. So we're going to subtract the 3,000. So I'm going to have negative 3,000 equals negative 150 W. When I divide by a negative 150, that'll give me a positive answer, right? You can absolutely use your calculator here, but also realize you can get rid of some of those zeros. 30 divided by 15 is 2, so 300 divided by 15 is going to be 20 weeks. So he's planning ahead. He knows that in 20 weeks he'll have enough money to go and get that car. If you have someone that comes to your house to do some kind of work for you, like a furnace repairman, for instance, a lot of times they charge an amount just to come to your house. And then they'll also charge per hour. That's just how a lot of those kind of services get figure out their bills. So this $85, that's how much, that's like the service call. They're going to charge you that just to begin, just to get to your house. And then it's going to be $65 every single hour that they're working. So if I want to write the cost for this, the cost is going to be $65 for every hour. And it was $85 just to get there. All right, so that's the situation. And after they're all done, the repairman sends you the bill and it's $280. So I want to know how long they charged you for working at your house. So our equation again is C equals 65H plus 85. And again, I want you to think about where that 280 goes. Is it 280 hours? No, that was the total cost for this, right? So I'm going to put that in for the cost. This is $280. Now, solving this equation, we would first get rid of the 85. So 280 minus 85 is going to be 195. And then we would divide. And this is going to give me 3. So that's 3 hours that they worked. Okay. Now, if this repairman worked for 2 hours, how much would he charge? And again, I could totally see you doing this without an equation, just saying, well, $65 for each hour and then add the 85. It's really what's happening in the equation anyway, though. So I would have the cost would be $65 for each hour plus that initial fee to get there. So 65 times 2 is going to be 130 plus the 85 is going to be $215. Okay, I hope that those made sense, just figuring out which number has to go where. So today's worksheet is writing linear equations, taking situations, writing the equation that goes with it, and then knowing where to substitute for each different situation. The answer key is in Schoology, just like always, and when you're done, make sure you take the formative. Let me know if you need any help.